Welcome to UnweaveNet, Unweaving Activity Stories. We propose a new representation of video that is produced by a model called UnweaveNet. The thread bank represents the video seen by UnweaveNet so far and explicitly models the past activity threads. UnweaveNet scans the video from beginning to end, processing the video one clip at a time. At each point, it determines whether the last clip belongs to an existing thread or is the beginning of a new one. Having made this decision, UnweaveNet then updates its thread bank.
Thanks, Will. Let me introduce the UnweaveNet architecture. At each time step T, UnweaveNet receives a clip from the ongoing video, VT, and considers the current thread bank, ZT. UnweaveNet has two components: a controller that determines whether the clip continues an ongoing thread, resumes a paused thread, or starts a new thread. The prediction of the controller, YT, is passed to the thread update module, resulting in a new state of the thread bank at T+1. The controller is modeled as a transformer encoder. In this example, we visualize a thread bank at time T with three threads, Z1 to Z3. UnweaveNet learns two linear embeddings, a thread embedding and a clip embedding. Both produce an output of the same dimension E. We also learn an encoding of the same dimension to represent a new thread. The UnweaveNet transformer is then modeled, so it takes as input the embeddings of the current clip, all threads, and the new thread token. It outputs a corresponding sequence of contextualized vectors for both the clip and the threads. The contextualized clip is compared against all threads, resulting in the vector of logits. The relevant thread is accordingly updated. Importantly, UnweaveNet is trained end-to-end, including the backbone for clip features. This ensures the clip and thread representations and embeddings are optimized along with the controller's parameters. Decisions made by the controller are supervised in training using teacher forcing. At each time step, the thread bank ZT is populated according to the ground truth assignment. A loss is imposed on the output given the correct decision from the ground truth, with focal hyperparameter due to the imbalance in the decisions. We propose self-supervised pre-training for UnweaveNet. We start by sampling a thread and clips. We then position these within the same video. We use the same video to avoid trivial synthetic stories. We enforce a minimum separation between threads. We also vary the gap between clips for additional complexity. We then randomly interleave these clips, respecting the order of the clips within the same thread. Our self-supervised proposal produces synthetic stories for which the ground truth is automatically available, thus training UnweaveNet on hundreds of thousands of these synthetic stories. We also collect a reasonable number of annotated activity stories. Through an interface we describe in the appendix of the paper, we train, validate, and evaluate on untrimmed videos from the large-scale Epic Kitchen's 100 videos.
Now we show a video through the eye of UnweaveNet. Each time it receives a clip, it produces a score indicating how likely it is that this clip belongs to one of the threads within the bank. This is shown in the bottom left corner. Now the person transitions to a new activity, serving the potato taken from the oven. UnweaveNet detects the transition, creating a new thread within its bank. Following this, the person then switches to yet another activity, recycling the foil. UnweaveNet successfully picks up this transition too. Now we show some additional results. Clips are annotated with their index in the top left, the predicted thread in the top right, and the ground truth thread in the bottom right. Below each clip, we show the probability of the clip belonging to each existing thread, whether it begins a new thread. The descriptions shown below each video are purely annotated to support the interpretability of these examples. They are not used in training UnweaveNet. These two examples demonstrate UnweaveNet's ability to continue an existing activity thread, even under quite large visual changes across clips, as can be seen in the bottom example. In this example, UnweaveNet detects the transition from dicing meat to rinsing cleaver, and is then able to detect the dicing meat activity is resumed at the end of the video. In this bottom example, we see that UnweaveNet has successfully detected the activity transitions from setting up the washing machine to recycling the empty bottle to washing hands. UnweaveNet can over-segment video, splitting it into too many threads. UnweaveNet can also capture transitions between activities at the wrong time, like in this bottom example where UnweaveNet detects a transition later than is annotated in the ground truth.
See you at our poster.